科普中国。
NASA mission seeks lunar air, presented by Science at NASA. Back in the 60s and 70s, Apollo astronauts circling the moon saw something that still puzzles researchers today. About 10 seconds before lunar sunrise or lunar sunset, pale, luminous streamers would pop up over the gray horizon. These twilight rays were witnessed by crew members of Apollo 8, 10, 15, and 17. Back on Earth, we see twilight rays all the time. When the sun sets, shafts of sunlight penetrate gaps in clouds, shadows lance across the sky as the day ends in a rosy glow. The airless moon shouldn't have such rays, yet the men of Apollo clearly saw them. A NASA spacecraft is going back to the moon to investigate. Slated for launch in September 2013, the Lunar Atmosphere and Dust Environment Explorer, LADEE for short, will seek out twilight rays and other mysteries of the lunar atmosphere. Yes, the moon does have an atmosphere, says Richard Elphick, the project scientist for LADEE at NASA's Ames Research Center. It's just much more tenuous than ours. The moon's atmosphere is so flimsy, about 10 trillion times less dense than Earth's, that a good sneeze would rip through it like a hurricane. Lunar air is a gossamer mix of argon-40, which seeps out of the ground due to radioactive decay in the lunar interior, plus elements such as helium, sodium, and potassium, sputtered off the lunar surface by solar wind and micrometeoroids. None of these gases appear in sufficient quantities, however, to explain the twilight rays. We're missing something, says Elphick. The missing piece might be dust. When sunlight falls on the moon, solar UV radiation electrifies the unprotected topsoil, possibly causing lightweight grains of moon dust to rise off the ground, joining the gases already there. This electrically charged dust may be what the astronauts saw, says Elphick. LADEE's lunar dust experiment will collect and analyze dust in the moon's atmosphere to test this hypothesis. Researchers have a special name for atmospheres as fantastically thin as the moon's, an exosphere. On Earth, molecules in the thick air are constantly bumping into each other, spreading pressure and heat in all directions. In an exosphere, however, molecules are so far apart they rarely collide. Instead of bumping into each other, says Elphick, they bump into the lunar surface. Air molecules coming into contact with the moon's dusty surface are expected to stick briefly before moving on again. Hop and stick, hop and stick. At any given moment, millions of molecules could be hopping like bunnies across every square inch of lunar terrain. Ultraviolet, visible light, and mass spectrometers on board LADEE will inventory the molecules present and determine how they behave. The dusty, flimsy mix of atoms and molecules in the lunar atmosphere is sure to have alien properties that our experience on Earth has not prepared us to anticipate, says Elphick. To find out, LADEE will be working on a deadline. On April 15th of next year, the sunset-colored shadow of Earth will envelop the moon for a lunar eclipse. It will be a grand sight from Earth, but bad news for LADEE. The spacecraft is solar-powered and requires sunlight to charge its batteries. An eclipse could end the mission. The current plan, says Elphick, is, before the eclipse, to guide the spacecraft into the surface of the moon for a final impact that we can study. We'll be taking data until the very end. For more news about lunar mysteries, airy and otherwise, stay tuned to science.nasa.gov.
科普中国。